Welcome to a new test and teardown video. This time we're just going to have a look at a very tiny little product. It's from a company called Kathrein, and this one is a remote control unit. It is specially designed for tower mounted antennas like GSM antennas and cell phone stuff, and it's actually a mechanical remote control unit, so it consists of motors and stuff, and then a digital serial protocol and a power supply via this watertight DIN type of connector. They can also be daisy chained, so some models actually got two connectors, but they're just connected together, and then the serial protocol just goes straight through to the next and to the next unit. And this one was used for a remote tilt. So it's actually moving parts inside the antenna. So you don't need to crawl up the tower and mechanically adjust the tilt for better coverage of some areas. Sometimes you need to adjust this, and it was definitely a thing in the old days to go and crawl up the towers and adjust the antennas. And then all these mechanical adjustment units with motors and stuff, they were invented. Today they are doing a lot of this pan and tilt remote control using a phase, controlling the phase arrays of many multiple antennas, and this way controlling the angle of the antennas electrically. No moving parts, so that is super sexy solution. They added some goopity-goop here, as you can see, just to make it more watertight. Of course, this is directly outside in the sunshine and also in the rain. So maybe we should have a look inside this unit. It's Torx 10, so it should be fairly easy to open. So now we're inside this unit, and now, of course, I know why this was thrown out, because as you can see here, we had some water leakage problems. And that is a classic problem with telecom equipment. It ends its life looking like this. So this is definitely aluminium DCs, and this is mounted down like that. So water that enters this unit just go to the bottom, and then it's supposed to go out this drainage like that, but it just didn't happen. And it's just really badly corroded here at the end. Whoa, look at that corrosion all over the place. And here you see the cascaded connectors. They're just in parallel, male, female, so you can just go to the next with a one-to-one cable. And this is actually quite interesting, this piece of electronics here. So first I want to show you the little motor unit, and see there's a rod sticking down here from the antenna, and it can move. I think it is a half a rotation, and then this motor is of course heavily geared, and this is a stepper motor, kind of synchronous motor with Hall sensors. And then the windings and the Hall sensors goes via this micro match connector to the controller board. But look at that one. See, there's a coil, and this one is right here. The PCB was mounted like that, right? So that means, no, I think it was like this, right? So when this rod from the antenna rotates, you get a signal here that is of different amplitude. But the fun thing is, there's actually an RF chip in there as well. So here is a little RF reader chip. So it's communicating with the end of this antenna. We hear some low-speed wireless inductive communication, right? And then there's an ARM STM32 and we got a low speed and communication protocol. Oh yeah, and a lot of protection parts. As you can imagine, this one is mounted directly under the antenna. I mean, on the antenna, and the antennas, they are mounted at the highest point of the towers. So that means lightning events will happen, right? And it will create all sorts of voltages across the communication cables versus the chassis. So look at all those components used for protection. 2 in parallel, yeah. We need all the power we can get. And double diodes down to the fuse, and look at the thickness of the tracks and stuff. Yeah, that is definitely a direct threat to this unit. And here's a little power. No, this is the driver for the motor, right? A beautiful 4-layer PCB. And this is a classic telecom product. I just wanted you to see how the protection and all this power supply stuff is done. And of course you have those resistors. And that is, if you don't have those resistors in series with your gas discharge and your transorbs, your peak currents, they're just going to go way higher than all those components can handle. And those are like 3000 watts peak each. Yeah. But with the resistors in series, that is definitely a good trick. This is always how we did it when I used to work in telecom. The resistors, the gas discharge and transorbs and diodes and all that kind of stuff. And of course capacitors, and that is, yeah, super standard kind of stuff. This is how you do this. So that is kind of all I wanted to say about this unit, and then I will probably just throw it out because it's, yeah, of no real use anyway. Maybe we should have a look inside this gearbox. Maybe I can use that for something funny. So here's inside the gearbox, and look, it is of course a planetary gearbox, and it's actually 2 sections, as you can see here. Wow, that is so nice, and it runs so smooth. Beautiful. Yes, exactly as I said, a 2-section planetary gearbox. And look at that, the first one here, this is the output shaft. That is made a lot more solid because the torque here is much higher. And the first section on the motor, that's made for higher speed and less torque. So last I want to show you how this unit looks when it is mounted on the bottom of an antenna. And thank you very much for watching. See you soon. Bye bye.